Alright, for this video we're going to talk about functions versus non-function. What's a function and what's not a function, basically. And to keep it simple, we're going to write ourselves some definitions and kind of set up a little table. So definition of a function, and then we'll do definition of a non-function. So again, pause the video if you need to and write this down so you kind of catch up with me. So most everything we've been doing in algebra this year is considered a function on the left side of this table. We've been graphing lines and parabolas, absolute values, and like in the last video we learned how to do square root functions. All of those land over here. Basically what a function is it's a graph or a rule, but it's a special type of rule. So we're going to write this out. A function is a rule, table, and graph, because those are the three things that we practice a lot of. A function is rule, table, and graph that for every input there is one output. For every input, there is one output. So that is our definition. A function is a rule, a table, or a graph that for every input, there is one output. And that means every time you put something into the rule, you get one thing out. And what I mean by that is something like this. If I give you an in and an out table, in is the x's and out are the y's, and I walk in and I start building this table, and I put the number 3 in the table, and I plug 3 into the rule, I bubble it in, and out comes the number 5. And then I put 7 into the rule, and I get 9, and I put 8 into the rule, and I get 20. I get a bunch of numbers. And then somebody else comes along, in walks in my cousin Johnny, and he does the same thing I'm doing. He kind of starts repeating. He tries to put the 3 in again, so he didn't see that I had already done some work. What do you think Johnny's going to get when he plugs 3 into the rule? Yeah, he's going to get 5, just like I did. We're going to get the same answer because there's only one answer. This is what a function is. We get the same output, the same out, or the same y value. The same out for the same in. If we put 3 in, we get out 5. That's not what's over here. Non-functions, you can get different answers. So here's a definition of a non-function. Non-functions are rules, tables, and graphs. Non-functions are rules, tables, and graphs that for some inputs, there's more than one output. There is more than one output. That's a definition of a non-function. So non-functions are rules, tables, graphs that for some inputs there is more than one output. In a table, here's what that means. I build a table with some rule. I don't have the rule in front of me right now, but I start putting numbers into my table, and I put the number 2 in and I get 8, and I put the number 3 in and I get -4, and I put 5 in and I get 12. I get a bunch of numbers. But then Johnny walks in again, and little Johnny, he comes in and copies me, and he puts the number 2 in again, even though I already did it earlier. When I put 2 in, I got 8, but when Johnny puts 2 into the rule, he gets 3, a different answer. That's not a function, and we haven't had that happen to us all school year, but it's going to start happening. Two answers, or 2 outs for the same input for x equals 2, all right. We got 2 answers for x equals 2. We got 8 and 3. That's what a non-function is. When you get 2 answers, or what if I put 2 in and I got another answer, a third answer? That's not a function. So here's what it looks like in a graph. Let's keep this table going. We're going to make it big. In a graph, a function is pretty quickly identifiable. It's easy to do. So I'll show you what a function looks like. One function we really know well is parabolas. So I'm going to make up a parabola that looks like this. And I don't know the rule. I haven't made up a rule for it yet. But it doesn't really matter what the rule is. I'm going to put some numbers on this graph. I'm going to say this middle point where the vertex is at 4. And I'm going to say the roots here cross at 2 and 6. So here's 8. I'm just putting some numbers on the graph. So it goes 2, 4, 6, 8. So the roots are at 2 and 6. Now, I know this graph is a function because I'm going to name it f of x with function notation. And I could say, I could ask you lots of questions. Like I could ask you, what does f of 2 equal? I could ask you, what does f of 4 equal? I can ask you what f of 6 equals. And every single time I ask you this question, you're only going to give me one answer. F of 2 is right here. This is f of 2. And what does it equal right here? Well, go over on the y-axis. Where is it at? 0. F of 2 equals 0. F of 4 is right down here. Here's f of 4. And what does it equal? Something over here in the negatives. Let's say it's down here at -3. So f of 4 equals -3. So I'll write that here. What's f of 6? Well, f of 6 is right here. And it's equal to 0 on the y-axis. So f of 6 equals 0. Well, if I came up to you again and said later on, hey, can you tell me what f of 2 equals? You're going to give me the same answer. It's still 0. It hasn't changed. There's only one answer right here, 0. That's a function. But a non-function, I could have two answers. What if I did this? I drew the same type of graph, but I flipped it. I turned the parabola sideways, so it looks like this. Now that's a totally different graph. I'll call it f of x, even though it's not going to be a function. It's not a graph we've seen a lot of, but check this out. Here's 2, let's say. Here's 4. Here's 6. If I went to 2 and said, what is f of 2 equal to? You would give me two answers. You'd say, well, okay, here's 2 right here. So what's f of 2? Well, there's a point up here, so here's f of 2. But there's also a point down here. Here's f of 2. There's two answers. There's two spots where the graph hits. Up here, we could say it's at 3, and down here we could say it's at -3. So f of 2 equals 3, but it also equals -3. So you'd say f of 2 equals 3, and f of 2 equals -3. We've got two answers. That's what a non-function is when you get two answers. And this drawing a line sometimes helps, because if you see the line goes up and down vertical, and it hits twice, you know it's not a function. If it hits 3 or 4 times, it's definitely not a function. So we call that in Algebra 2, we call that the vertical line test, but it's just a straight up and down line. So for this last part, I'm going to make up a few graphs here and show you some different things. Like, let's say I have a graph. This would be a wild graph. This would be crazy. It's a spiral. And I ask you, is this thing a function? Is this graph a function? I would quickly say no. If I draw a line going down right here, let's say this is at 2, and I said, what's f of 2 equal? Look at all the answers you would give me. You'd be like, well, it's here, and it's here, and it's here, and it's here. There's 1, 2, 3, 4 points at 2. 4 answers. So is this a function? No, definitely not a function. Fails that test. What about this graph? What if I drew a graph and the graph was a perfect circle like this? Perfect circle. Function or not a function? Well, draw a line up and down. Let's say I drew this line at 3 and I asked you what f of 3 equals. How many answers would you give me? 2. There's one here and one here. There's two answers. So is this a function? No, definitely not a function. What about this graph? I don't think you've seen this graph before, but you're going to learn about it in geometry, I think. It's a graph that goes like this. It's a trigonometry graph. It's a crazy looking graph. Kind of looks like this snake goes back and forth. I didn't do it very nicely, but it looks like this. Is this graph a function? Does it pass the test? What do you think? Well, draw a line. Does it hit more than once? It only hit one time there. Well, how about over here? Does it hit more than once? Oh, it only hit one time. What about over here? It only hit one time. I'd say yes. Passes the test. You only draw a line and hit the graph at one spot. So is it a function? Yeah, totally. Vertical line test. Okay, so last one. Let's draw one more graph. How about a square root graph? Because we just learned about square roots. Square roots are the graphs that look like this. This is y equals the square root of x. Is this square root graph a function? So if I draw a line right here, does it hit more than once? It only hits one time. What about here? It only hits one time. What about here? It only hits one time. So function, question mark, is this thing a function? I would definitely say yes. Yes, because there's only 1 point, 1 point, 1 point. So that's the big difference between a function and a non-function. What you really want to make sure you remember is these definitions. A function is a rule, table, and graph that for every input there's one output. Non-functions are rules, table, graphs that have some inputs that have more than one output.